We're now going to look at an example of how to use the delta tags framework for incremental reloads. This example will be based on the previous example we used in the incremental extracts section, since that way we will be able to compare this approach versus the one we used earlier. To start, let's look at the actual delta tag script. You can find it on the script subfolder. As we can see, it has several configuration variables at the very start of the script. The first one is used to define what is the starting point for all full loads. This is something that you can set globally, so all your scripts where this is implemented use the same value, but you can also override it on specific scripts if needed by simply declaring the new value in the load script. The second variable is used to define a buffer time. For instance, if we last refreshed the data at 2:30 p.m. and we have a buffer time of 10 minutes, the next time we query the data, it will use 2:20 p.m. as the starting point. This buffer time is completely optional and is just to avoid any potential data loss, but you can also set it to 0. The other variables can be left as they are. They don't need to be changed since they are internal variables used within the script's logic. We also have to define a couple of variables in our load script before we start using the subroutines in this external script. The two variables we need to define are the last check type, which can be one of two options, runtime or inputs. Runtime is used to set the starting point timestamp based on the last time that the script successfully ran. This is basically used for scripts on the extract layer. Inputs is used to define the starting point based on when the input QVDs were updated when we last ran the script, not on the actual time when it ran. This is used for scripts on the transform layer, and we will see an example of this later on. The other variable is used to specify whether or not we want a forced full reload. This is simply a binary flag, so possible values are 1 and 0, and we can use it when we need to reset the data in our QVDs and do a full reprocess of the data. Another way in which we could force a full reload is by deleting the output QVDs from disk, and the delta tag script will deduce that the QVDs need to be recreated in full. Finally, as one of the outputs of this script, there will be a variable with the calculated starting point timestamp based on the configuration and on the tags from existing QVDs. We will then use this value to query the database for new data. I will go ahead and open the example we used in the previous section for incremental extracts and modify it to use the delta tag script. In the previous example, I used Qlik Sense to demonstrate the concept, and now I'll use QlikView, but it's the same script that we saw earlier. As we can see, this script has the configuration variables to keep track of delta reload times. These variables will be replaced in a moment. The first thing that we're going to do is add the include statement with the delta tag script. Then, we need to specify the QVDs that are involved in the script. Since it is an extract script, only one set of QVDs is involved, and that is the output QVD. In transform scripts, we would have both inputs and outputs. There are several ways of doing this, but by far the easiest one is by using a function where we can just specify the path to the QVD and the name of the field we want to use for tagging the values, as well as the type of QVD, whether it's an input or an output. Since we're dealing with segmented QVDs, we can specify a file mask using the star symbol. Next, we will go ahead and declare the two variables that we will need. The first one, since it's an extract QVD, will have the runtime option. The second variable, which identifies a full load, will have a hard-coded value of 0. Even though we're using this value as 0 to indicate a delta load, the script will automatically detect the first time it runs that there are no QVDs and therefore will do an initial full load. Once we have this set up, we can call the first subroutine. This subroutine will attempt to read the tags in the QVDs that were registered in the previous step and determine the query timestamp based on the status of those QVDs. The result will be a new variable, which we can use directly in the query. However, I will separate it from the other load script variables just for good measure. Similarly, I will keep an internal variable to store the full load flag, since we will need it for the segmented QVDs subroutine. Setting this variable after the startup routine is important, since the value defined previously may change after the startup script runs based on whether or not we have QVDs in the first place. The first time this script runs, this variable will change from 0 to 1. Now that we have that, the next thing that we have to do is call another subroutine after the data is loaded from the database. This subroutine will update the tags on the fields with new values so that they are stored along with the data in the QVD. At this point, we can go ahead and reload the script. Since there were no QVDs in this first run, the query timestamp is the preset value of January 1st, 2012, which is what we currently have set in the external script. After a few minutes, the reload has finished and we can see all monthly QVDs were updated. The data we're using for this example has 10 million rows for this table, and each monthly QVD has roughly 1 million rows. The total execution time was 4 minutes, and at this point, all the QVDs that were created have been tagged with the last checked value of the time when we ran the script. I will open a separate document with which we can inspect the tags in these QVDs. I've already set it with the proper configuration, so let's reload. I have all 12 QVDs listed, and we can see which field has which tags. Since I specified that tags should go on the ticket ID field, let's select it from the list. We can see it does have the new tag we created and has the proper times as expected. This tag will exist for all QVDs, but only for the field we specified. I will go ahead and rerun the extract script to see if it identifies the tags. We can see that it is querying the data based on that tag and on the buffer time that we defined. And at this time, the data doesn't have any updated rows. Now, I will run the script that we have been using to randomly update the database. It already has the configurations that we added in the previous example, so I will just update it to make sure that, this time, only 2 months are updated, November and December. Now I'll go back to the extract script and refresh the data. We can see it's still querying the data based on the tags that exist on the QVD files. It returned a few rows for November and December, so only those 2 QVDs were updated. I will go to the Tag Viewer document and reload it to look at the tags on those QVDs. We can now see that there are 2 different tags with the timestamps. The first one is the one we had earlier, but it's only associated with the QVD files that were not modified in the last script execution. The new tag value is associated with the QVDs corresponding to November and December. At all times, we should only have one of these tags per QVD. I will update the database once again and, this time, limit the updates to the month of December. I will then rerun the extract script, but before I do that, I will make a backup of the December QVD file. I'll put it in a separate folder. Also, since this time I want to make sure I only load the latest updates, I will reduce the buffer time window to just 10 seconds. As I said, this can simply be 0, but just in case. Okay, I will run the script. And we can see how only the December QVD has been updated. What this means is that now we will have 3 different tags, but on different QVD files. The most recent tag is on the December QVD, the previous one on November, and the other in the rest of the QVDs. One of the nice things about using tags on the QVD is that we get more consistency in terms of how the data is updated, as well as that it's very fast to check when each QVD was updated. If I run the extract script once again, it returns 0 rows because there haven't been any updates since the QVD was last refreshed. But let's suppose that the QVD file got corrupted or changed, and we had to restore from a backup. I'll simulate that with the copy I made earlier. And what happens is that the script will query the database based on when the QVD that was just restored was last refreshed, not based on the last script runtime, which is what the previous approach was doing, based on variables stored in the QVW, not on the QVD. In that previous scenario, we would be losing some rows, but not on this one where we're using the delta tags framework. That's why the delta tags approach is so convenient and preferred over the other alternatives. We've just seen how this can be used in the extract layer. We're going to see how it's used in the transform layer in a later section. Before we move on to the next section of this class, I'd like to make a quick note regarding compatibility of the delta tag script. Even though the tagging functionality has been available since QlikView 10, there were issues with how reliably these tags could be updated using the script, which prevented this from functioning correctly. Even with one of the first releases of QlikView November 2017, there were issues. The newest release doesn't present any issues with tagging via the script, so it's recommended to implement this approach with the newest releases of QlikView and Qlik Sense, which, as of now, are QlikView November 2017 Service Release 5 and Qlik Sense April 2018.